It's not much more in the grid than mines. I guess I could just get it. There. Okay. Let's make it a little bit smaller so I can put even more on next to each other. Let's keep it non-square just to make sure that that works. Okay. Now, I want to know where I can click first. And where I can click first is something. What I want to know actually is that the thing is solvable without guessing. But that's impossible unless you click on something where you know that there is a mine, and that wouldn't help. I mean, this is just edge, right? That doesn't participate in the game. So this is on the edge. If I would click here, I would get 1, 2, 3, 4, 5 in it. And since there is only 5 possibilities where mines can be, I know that all 5 are mines. And then I can click them, 1, 2, 3, 4, 5, but that doesn't help me. Then I'm stuck. Then I have to click somewhere else, and I have no information whatsoever. So I could accidentally click on this one, or well, any of the other mines. Same for wherever you click. If there is a mine next to it, even one, then you don't know which one. So just you still can't click anywhere. So you click here, there's a mine next to it. So if you click here, that says 1 and 1 mine. So you know that that one, that one, that one, that one, or that one is a mine, and therefore you cannot click anywhere if you don't want to guess. So the only first move, the only acceptable first move is a move where you get a 0. And that would be only this one here. This one is next to no mine whatsoever. I'm thinking about adding a color for the top row and the beginning and the end of those things. So that, let's say, make all these different color, or maybe make this a different color. Leave those white. So somewhere I'm having print row 1. Defined here. Here's my colors then. We have bright. I want gray. Black, red, green, yellow, blue, cyan, white. There's no gray. Guess I could use this one. 238, maybe 8. 8 looks good. Oh, let's use this one. 3858M. Should work on my terminal. I need a color reset after this. Basically at the beginning. After this as well, I guess. After the last column. Right, so what I was saying, we need to begin with clicking on a field that does not border any mines, because otherwise we have to guess, and I only want to give the first move for free. After that we have to be able to solve it without guessing. So in this case there would be no solution. In this case it would be like that one, these two actually. They border on no mines at all. And this one also. How do we find those? Well, we have a few nice tools that I wrote yesterday. So what they can do is explode all mines, which means that they are adding 1 to all the neighbors. And then the field that remains 0 borders on no mine whatsoever. And that itself can also not be a mine. So we need to explode the mines, find all fields that are equal to 0, and then subtract all known mines from it. What we are left with then is all the possible moves. So let's do that. I'm going to do that at a new row, I guess. Now maybe let's just add a function for that. Find first move. Just a random name. Let me return something. So this returns a bool vector which has a true set for everything. Okay, possible first moves. Nope. Okay, so we do the following. We get all the mines. And then have to explode that. So this is, I call that all as borders. So the border count, whatever. It's the number of mines that are bordering the current square. Is mines.explode. Explode looks like this. We just shift the whole field in 8 different ways, and then add them to the result. So in the end, then every square gets added 1 if for each neighboring square that has a true value set, true being 1 in the vector. Let's print that one out. Let's see, vector explodes is signed. I want to set a label on it actually. Let's call that set name borders. Alternatively, we can just pass or create a copy constructor thing that takes a name. Both work, but well. So I just copy the data, the data array, and the name is not copied. The name is then set. to the new name. And then we change this to construct borders. Copy whatever is returned by that thing. Okay, I'll show the result of that. Borders. What the hell, man? Right, all. Yep, so here's the borders after exploring these mines. So you can see that it doesn't work, or does it? Oh, it doesn't work. I was thinking the 7 is not right. 1, 2, 3, 4, 5, 6, 7. Yep, so that's the 7. Furthermore, you can see that we have only 2 zeros here. So those are the only 2 possible begin moves, because these 2 are the only ones that do not border any mines at all. So now I have to convert these zeros into a 1, and the rest must be 0. We can do that as follows. That's exactly it, I think. So I wrote a tool equals returns a bool vector, which is what I want. So could do it like that. So we do borders dot equals well, 0, whatever. However, 0 must be a vector with 0 everywhere. In this case, that's quite easy because the default constructor makes a vector that is all zeros everywhere. But it being a dot CXX file, let me just make an anonymous namespace and put there a 0 in. So this is just a vector 0. There we are. That's const. So what this equals should do is it should return a bool vector where each element or each square, each field, whatever, gets a true value when the element of borders equals 0. And that works as follows. I mean, I'm not going to loop over all squares. No, 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 no. We do something sophisticated. Do an exclusive OR with the value. In this case, that doesn't do anything. Exclusive OR is all zeros, well, no op. And then we run over all elements of data. So that's not a single square, that's a whole 64-bit integer. And so that contains like 16 squares at the same time. And then we run equal 0 on that, which is then implemented like this. So it's just for assuming that in this 64-bit integer, every bit is a separate element, and we find then the elements that are all zero, which is done by, this is just a constant generated by a const eval function. And then we do a quick loop, which is basically logarithmic in the number of bits, so it's just extremely fast. Should work. Oops. Right, cool. I'll make. Except that I'm not printing it. Oh, I am printing it. Okay, now you can see what goes wrong here. This square does not border any mines, therefore it gets a 1 set. But it's not a solution because there is a mine at that point. If this would have been a 0, then it was correct. So we have to remove all the squares that are mines from this answer, and nothing is left. Then we don't have any solution at all. There is something else wrong. It also sets ones in the border where we cannot click. Let's keep those at 0 as well. I do need a vector that just has the whole inner square as set. I think I already have that somewhere. I think, or not. No. No. We need that. How are we going to do this? I should edit this one. So result clear mines. I'm gonna make that a separate one, I guess. Just like well, it's quite obvious how this one works, right? So just every element that is set to true here is removed from the result one. It's exactly what you want, of course. Clear is implemented like this. Again, just a loop over the elements of the array, just per 64-bit at a time. This will still give us edge things on the edge. So we should do also clear edge. And then I need a vector that has a true set for the whole edge. So bool vector is that. I think clear only takes a bool vector, right? It takes a vector. Well. A bool vector is derived from vector, so it should still work, I think. The edge, yeah, the edge must be... So just make it const. I wonder if I should make it const expression. And can an array be const expression? I guess it can. Let's try const expression. Can even make this one const expression then to try. It implies const, so let's remove that. Generate edge bits. Oops. I think that before I can make a 0 vector, that is const expression, we need to make constructor const expression. And that means that this has to be const expression. Not even sure if that's possible. Okay, that would be this one. Probably is possible as long as you pass a const expression to name. We're just going to try it, I guess. And then I want a const eval generate edge. This is a template int bits. Give me some more spaces here. Well, I think returns a bool vector. If it's const eval, then the compiler will definitely run it during compile time, and then just use the resulting value. So I can just think of anything that the compiler can run here, just only using constants. Okay, default constructor was a const expression. It doesn't even matter anymore, I think. You can use whatever you want inside this function. But now it's all zeros. And I want to set what's a smart way to do that? I guess we don't need a smart way. It's just compile time anyway. Or even one time. That wouldn't matter. Now I make this depend on, okay, it's orthogonal to bits. It's probably okay to run over all columns and all rows. but we just want to have the, yeah, it's kind of silly. I could do this if I just want to set the inner stuff. Maybe I need one for that as well. In the end, I'm probably going to need that anyway. So let's make another one, generate inner. Just the playing field in the inner rectangle. And then I'm going to set that. And here we just, I don't know, invert it. Not sure if I have an inversion actually, but we'll just add one. Okay, so then we want to run from call 1 and from row 1 to -1 and -1. And then for each of those we need to set value. So edge, set value, 1 or something. How does set value work again? Set value, value index, comma value. I have the feeling that this works except for the operator tilde. Let me try to compile it. Not exactly. No matching function for index. I need to pass the class, of course. Index is static. I can just use vector. Const expression expansion for generate inner 4. Call to non-expression function. Oh, it's inside. It must also be const expression. Guess that makes sense. Set value. Okay, so set value must be const expression. No big deal, I guess. I just tell it to be const expression. Is that going to work? Well, why not? Yeah, it's just calculating. It should be const expression, I hope. Redeclaration. Set value differs from. Oh, wait a minute. You have to repeat that here. And then we get the same problem for index. It's also being used. Index must be marked const expression. Well, if anything is const expression, it's a static function like that, right? Yeah, So now that compiles, but the operator tilde is still missing. So we need a tilde for the bool vector. Which then also must be const expression. We shall add it just here. Bool vector operator that const. Did not inverse it yet, but I want to see if it compiles. Did. Yeah, how to inverse that? Basically, XOR with the Boolean vector. Oh, Boolean mask. Oh, yeah, we have that here. Very good. But then this must be const expression. And it isn't, because I'm filling it later, I think. Interesting. How do you do that? So Boolean mask is generated by, yeah, it's not a const expression, of course, not like this. Oh, the Boolean mask is only the inner rectangle as well. I wanted to invert everything. Let's not use that. That BM also stands for Boolean mask, but now I have to create it first, because that's a per word thing now. So I need an uint 64 type BM that equals Yeah, something like this. Let's create a 0 and then invert it and then divide it by hey, Alt Chesser. Okay, we have 0, we have all ones, and then this is of course a 1 followed by bits zeros. -1 is just bits ones, and that is a power of 2. So if we divide this by that, then we get the mask that I want. Any questions? No. Just ding. It doesn't compile. Static. Hello. Context expression static member boolean mask must have an initializer. Yeah. I changed my mind about this one. Assignment of read-only location. Ridiculous, but okay. It's just a constant anyway. Hey, it compiles. Yeah. What do you think? Well, that one worked. To maybe it totally works. So now this one is the only field where it does not border on any mine. We didn't get this one, so I'm guessing that indeed the whole edge has been removed. We did not get this one either. The edge is probably being removed, yes. Let's try a few more. No solution. Yeah. Again, no solution. No, that's not much solutions, but still correct. My God, this field. It should have a solution here. Yep. Let's look for something that has 3 solutions or something like that. 2. Oh, I should have tested it all. No, there are new chance. Those 2, yeah. So now I think this just works. Now we have one set at the places where we have squares without a mine under it that do not border any other mines. Then we have to pick one, or maybe just loop over all of them. And click them. If you mean what I... if you know what I mean solver. Of course I should have done that instead. Borders. That was for printing borders, but you don't need that anymore. And then we do this one, constructed from a name and whatever that returns. And the name is possible first moves with spaces here. Bit long, isn't it? So matching function for bool vector does not have that. Standard length error. I guess it was just too long. Yeah. I'm trying to add a negative number of spaces now. It's not allowed. None. Okay, there's 1, 2. Okay, wow, 4. All 4 here. Cool. Okay, so next we want to click one of them. Nah, I need a loop, I think. I need a loop that loops over all possibilities that we have. In fact, can I split this in 2 lines? First do that, and now we do possible first moves is that. I'm surprised it works. And then we can first move. We can make this a loop. Do that while possible first moves. Well, it's empty. How do you test that? It's empty. Why not? I have to add an is empty. So now, oh, it prints a lot. Find first moves is printing something. Oh, I'm printing the result. Yeah, didn't want to do that. Plus, we're hanging. That's not ideal. While that is, yeah, and then we want to regenerate the grid. if that happens. So maybe you should do just an infinite loop. If not empty, break. Otherwise, grid randomize. So we need a randomize that calls randomize on mines. No, we never have a 0 anymore. What? What? What was that? I still have it here. Wow. Something went wrong. And not a little bit. Oh, that happened more often. I miss it completely. Mine is not the boolean anymore. After a randomize. Yeah, randomize is filters with random data. That is not correct. So this is the constructor of grid. So you have to do that as well. Talking about grids. Whoops, that was missing. Yeah, that's better. Yep. Okay, so now we have to run over all the ones in this vector. I think I'll just get an index. Index is an int. Which always exists at the moment. What? Well, why not pretend that we didn't do this? And here I want to do indexes next true. No, I'm starting at the index, I guess. And now you have to write first true and next true. Part of bool vector. Int for index first true. It's not inverse. Do stuff, so if there is no 0 at all, now I return 0. But that would seem to indicate that the index is 0. But we can use that, I guess, anyway, because this should never be true in... maybe you should return -1 now I think about it. No solution there. So this is more like index is unequal -1. And if we find an array element that is non-zero, then we can find which is the first bit set in there. So we skipped 64 bits at a time per index. And now I want to get the first one. I think I just need to know literally the bit index, right? I don't know which one that is. It's not the CTZ. So I wrote the utils. Count trailing zeros. Yeah. So if there is no trailing zero, then there's return 0. So that would be the bit inside that 64 bits integer. Yep, totally correct. And then I have to inverse bit to index to return, well, bit divided by bits. Or not. Well, let's say the very first thing we find, the first bit is set in the first element, then this is just 0. And if the next one is set, then it is going to be equal to bits. So that's 1. That is the index. Okay, CTZ is defined as just calls built-in, whichever is the best one. And I need to include utils. Oh, didn't. Next true. Next true. It's probably even harder. So last was the last one that we found, and we want to go to the next one, which means that Phew. Mm-hmm. Let's call this just I. So this I is the value that we just returned here. That's not I. This thing was divisible by bits, exactly. So I can get back this value by multiplying by bits. Okay, let's call it last. So we do int bit is last times bits. Now I have bit back. I can get I back by dividing it by 64, because this is always less than 64. Now you have I back. And then you can get the value of the data at I. Now I have to reset all the bits below this point. So I need to have that value itself. To do that, I have an I. So int some more bits actually. This is a bit index. Let's call bit index here. I don't know, bit. What's in the name if you want to make progress? Bit equals, and then I want to have that thing, so that would be bit index minus 64 times I, probably the same as bit index modulo 64. So just do that. Looks more, I don't know, looks better. It's not really a bit, though I think about it. This is an index inside the uint. The bit was a bit index, isn't it? What? No, it is a bit index. Yeah, it's still a bit index. Both are bit indexes. So I want to convert this to a bit, and I have to shift this to the left. No, not that. I have to shift int 64 type 1 to the left that much. Then the next data value, let's call this a D, is then data, and then we remove all the lower bits. Should be OR remove and the inverse of that, I guess. Yeah. And then we need to get the new bit index using D. If D has become 0, then not. So I think I should just test on D equals 0. Does it say what it returns? Undefined when n is 0. Yeah, so let's not do that. I have to test for D 0. So if D is larger than 0, otherwise we have to increment I, so then we can just get the exact same thing here again, except that we start with I plus 1. Yeah, I don't know. I guess it works, but we'll see. I'm way too lazy to test it. We just go 1 times more over it. So last is this. Last is what is this value? This was totally divisible by bits, so multiplying by bits gives me the bit index again. And then I can do divide by 64, that gives me I back. And percent modulo 64 gives me this value then. So if we use that value to shift 1 to the left, then we get the actual bit that was detected here. If you subtract 1, then you have all bits set for low significant bits. Oh, right, that's not good. If I inverse that, then the bit itself is still set. Need to remove bit itself as well. So we remove that bit. All lower significant bits are also 0 then. So the number of trailing zeros is going to increase. But if it is 64, so the D is just completely 0, then we continue with the next index. And then just as if we did a loop here, turn to the top. And otherwise, yeah, we can just call CTZ on D and recalculate that stuff. No, it looks good. So this says index 10 here. Yeah? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8. Now we have 4 of them. 36. I'm going to count that. 1, 2, 1. This is 0, right? 0, 7, 14, 21, 28. 28 plus 7, 35, 36. That's correct. 37. And then, well, 40, 41, 42, 43, 44. Oh. Well, it looks okay, but the whole thing is even less than 64 bytes, so we didn't test something. Let's make it a little bit bigger. Like way bigger. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 27. I could have known that, but I didn't. 27 times 1, 2, 3, 4, 5 plus 1, 136. And then 137, that's the next one. And so from there to there is plus 27. 136 plus 27 is 163. 163, 164. And then we get this one, no, this one, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 27 minus 1, 2. 322. Yep. I'm already convinced. 498, so I guess I did not make a mistake then. So we calculate this one, just for fun, the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 times 27 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 plus 22. That is 724. Yep. Oh, I'm convinced. That works. Going back to this. So now we can loop over all the ones, and then we need to use those indexes, of course, to known empty, set known empty, right? So we just pick 1 1 and then set that bit that we got here in the known empty. That's our first move then. Solver dot set known empty index. Hey, Hyzens. I think I'm gonna do this slightly differently. Let's just store all of them in a vector. Possible moves. I'll first print stuff and then start doing it. And since it's just a move, I mean, I know that's empty because, well, let's test it. Click move. The effect of clicking on move, what is that? So my solver now gets a function void click int index. Which means that we need to set known empty like that, right? Maybe I'm not using the right word here. So with borders, I mean a vector with the exploded mines in it. So a number of the every square gets a little number, and the number is the number of mines that are bordering that. I could call it adjacent or something like that. Bordering, maybe. But again, I'm calling it borders. So now I have a borders, and I already had a borders because I use the same word everywhere. So instead of using borders here, now I can just use borders from the grid. And every time I randomize the grid, also borders are recalculated. The toggle header source, yeah, sorry, didn't understand that at first. When I read your last sentence. Toggle header source, dude, where did I put that? Dot config. Is either in Vim or new Vim? Needs? No. I have no clue. Init.vim. I was pretty close. Toggle. It's big. It's us. What are they going to do with this? Okay, I'll be nice to you. That's not working. Quit. 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 It's mostly complicated because I wanted to be intelligent with switching between CPP and CXX and stuff like that, HPP. So if you have multiple files, all kinds of extensions, then it switches the way that I want. In the end, it's just doing that. Okay, what was I doing? And I bound that to my F8 key, by the way. So I just press F8 and then it switches. So that's just a call. Well, this key is also very handy. Control H. Let's see if you can find that. Control H, probably something like this. Nope. Oh yeah, so this, you need that one as well then. But I guess you already know how to do that. Let's see if I can find my Control H thing. They automatically set the text file. Don't see it. But at some point, you get annoyed by the fact that if you have something highlighted, that it stays highlighted. You know, so I just search for something, now it's highlighted, and then you want to remove it. So and then I did something, and now I can press Control H, and then all the highlights disappear. I can't find back what that was. Solve a click. Yeah, that's what I was working on. C tags. Click. So here I set value on of a known empty. Yeah, why not just print again the whole grid after the click? The solver maybe. Let's print the solver. So the two possible moves after doing the first move. Actually, it starts here. No, doesn't. It completely fucks up. That's what it does. That's not changing. We don't know any mines. Known empty is going from all zeros to having that one set. And then it goes to having that one set and that one set. That's not what I want. I guess I also need to reset these things in the randomize. It's kind of a restart. But then this would have been a reset, and then we would have set that one, and that's totally wrong. You would think, well, the index is 40 and 47. That's these two. So how the hell can that lead to that? Set value is not working. possible. Let's first reset grid.h. Randomize. Yep, so set these things to 0, both mines and borders. Borders already. It's not what I wanted. No, I need a new solver. This is correct. Solver. Find first moves. Might as well make that. See, it's only using grid. Ridiculous. This should have been something of grid. Correct. Yeah, it's definitely not getting on the right spot here. Twelve to 19 is 7. How do I get 7 from here to there? It's even less, or 1, 2, 3, 4. That is nobody gets this. No, let's print it here and the out. CC notice of entering index. Unlock that. Oh, click -1. Click 47. That's strange. It contains 47 and -1 instead of 46, 47. -47 is indeed the last one, so that went correct actually. The -1 is just weird stuff. Yeah, okay, this is correct. 44, that's just the last one. For some reason we get the last one and -1. What if we have 3 of them? There are 3. More even. 5. Christmas. 8, 9, 10, 11, 12. And the first one looks like... That's funny. It's one past. It's one past that. Yeah, and then we get the next one, and the next one, and then the next one, and then the -1. Good. The -1 ends up there. So now we understand that, we can just do bitwise-OR. It has to be something incredibly stupid. Push back here after doing the index update. Yeah. That should help. That's almost scary. 6. 6 of them. Okay. 1, 2, 3, 4, 5, 6. Yay, that works. Nah, the click gives me now 1 known empty, but of course there is more, isn't there? Is there not more? Is that known empty the only difference? I think it is. Okay. I think I want to have a known borders as well. But that means that I want to show a 0 here. because it's not bordering anything. Yeah, I don't know. Probably need a known border, so let's add that to the solver class. Solver.h vector known borders. So we have to update. As soon as empty is updated, we must update that one. Empty is being updated in click. And it's only updated at index. So yeah, probably the fastest way is to just set known borders also at just one position. Using grid borders, the value at index. Hopefully that works. Do I have a value? It's probably called get value. I have a get value at some index, and that returns, that just returns the value at that point. And then we pass that value again back to this one with the same index, and then we put it in the other array. All masked, shifted. I don't think it gets any cheaper than this. Now, of course, that doesn't change anything, because the first click here is always on something that has a borders of 0. And I'm not printing it. Let's print it. Okay, next I want to know what else is empty. Okay, my statement is, I'll paste it in the chat. My statement is it's too long, of course. Beast, yeah. This is Minesweeper. You know in the game Minesweeper? So this is just Minesweeper. So we have this. These are the mines, just randomly generated. We don't know where the mines are. Everything is 0. We only know that this square is empty. And we only know about that square that it borders 0 mines. So this 0 means that it doesn't know no other mines are bordering there. That means that we can also click this one, and this one. Because there are no mines, this is 0, there are no mines bordering this square. That means that this is not a mine, and that's not a mine, and that's not a mine. How can we find these 3? And I just pasted it in the chat. It seems you can click on a square, so for example that square, because you know it contains no mine when it is adjacent to a square, that square namely, that borders n known mines. Now this one borders 0 known mines because no. And has an n inside of it. So it borders 0 known mines and it has a 0 inside of it. Therefore that is equal, and therefore this is one such square. And that one borders that, therefore you can click on it. Or all 3 borders that. So the first thing would be to get a 1 here. And that 1 is then here because it's known. There are no bordering mines. What is actually this 0? Sorry, this 0 is the number of mines that are bordering it. So there's no bordering mines here, but it is known. And that's not true. This 0 is the number of actual mines. That is 0. The number of known mines is also 0. But I have to create that by exploding the known mines first. So the formula for that would be what shall I add it? Click. I'll do it here for a moment. This should give us the mines that are needed. So we have the known borders. So that's at least that one zero that we have. Minus explode of known mine. So that becomes in the corner there, the right bottom corner. That element gets 0 minus 0. So mines needed is 0. And then we find all the squares that are 0 with this formula. So now this one, I think equals returns a bool vector. Yeah. So bool vector now has a true set for every square that needs 0 additional mines. But of course that only is valid if known borders was valid. So we have to AND that with known borders. So we can do help. Sorry, not AND with known borders. So we have to AND that with known empty. That's when the known borders is valid. And then we can calculate all the squares that now are known to be empty as well with this formula. The new empty ones is well, we just explode the has all and then reset that with all known things. So clear known. Because otherwise it would not be new. But also clear the edge. I don't have an edge here anymore. Let's keep a known separately. Let's see, I need known mines, I need known empty. For now I'll just do it like this. Okay, where's my edge? I think edge is in an anonymous namespace. Yeah, I don't want to do that then. Can I move this to a header? It's a const expression. Could make it part of solver maybe, or not. No. Using grid. put it in bool vector. Going to put it in bool vector, I think. Create.cxx. Okay, so if everyone understands this, what I pasted in the chat. So we want to find all the squares that are neighboring squares that have the same number of known mines already bordering it as that we see mines bordering it. So say you have a square that says 3, so we know that the total number of mines is 3, and we already see 3 mines, so 3 mines are known. Now we know that all the other 5 bordering squares around it cannot be mines, because we already have all the mines. So the way we find that is then as follows. So all the known mines are exploded. So explained that before, so just add 1 to all the neighboring squares, all the 8 neighboring squares. So afterwards, all fields of this vector has a number in it that is equal to the number of known mines. Yeah? And this is the known borders, which means that the number, this is a vector of elements with numbers in it that are equal to the number of actual mines. So we remove from the number of actual mines the number of known mines. If the result, that is the number of mines needed still for each square, if the result is equal to 0, then we have all the mines. So we produce a Boolean vector now that has true in every square where that vector has 0. In other words, we don't need more mines. And then every square bordering these things don't have any mines in it. At least the one that are not known. So what we do is we AND this with known empty. Otherwise that was not valid. So now it only has a true in it when this one was valid, aka we were sure that it's empty. Well, the neighboring things are empty. So we explode it again to get all the neighboring ones. And then we remove from that where already are mines, or where we already know that it's empty, and we also remove the edge from it. And now we have all the new empty things. Let's print that out. New empty. No, I guess this is my new empty. We didn't give it a name. But it's quite logical that this is the one that we clicked. And it has a 0 in it because there's no bordering mines. See, this is all no mines. So the bordering mines here of this one is 0, which is actually that 0. And we know it to be empty. So that means that all the things around it, all 5, are also empty. So we can click on all of these. Let's have a name above it. Known empty there, huh? Let's call it new empty, or new known empty, but well, whatever. So new empty, these 3. Why? Because we clicked on this one and it has no bordering mines. Let's see, we can even get more out of it. Something complexer. I want 2 of those things. Oh, it's never going to give me 2, of course, because you only click on one thing. Yeah. Okay, then this is all we get out of it. Maybe something in the middle ever. So all of this is on the edge. Why? Why is it always on the edge? Just generate too many mines. Oops. Man, it's really always on the edge. The chance that you have 8... Ah, there's one. That's not in the edge. This chance, of course, is significantly smaller than that a corner has no mine. So probably you should always click on the corner if you begin. No, that's nonsense. But, well, not nonsense. Say everything, there's a 50% chance. In this case, I have just 50% chance that there's a mine. Then wherever you click, you have 50% chance that you blow up. But if you click on the corner, then you have the largest chance to get a 0. And then you know that all these 3, is a chance of 1 in 8. But it's considerably better than clicking in the middle and then hoping that you have no mines around it. Right, so the next step is then to click all of these as well. Can I do that in parallel? I mean, just click all of them at once, not one by one. Because right now I have a click function, but it takes a single index. Can I make a click function where I just pass a Boolean vector, which has a 1 set in every square that I want to click? Well, that would be easy to make parallel. This is clicking actually. This is calculating the next empty stuff, and that is already in parallel. That's all squares at once. So only these two lines. Yeah, I just have to OR the known empty with it, and then do the borders as well. And get the value. Just have to. Yeah, I can do that. I can do that. That's like a parallel version of this. So first separate it. And this needs a new function then, which takes as input. Your minds explode. You are nothing. Doesn't take anything as input. Calculate new empty. Constant. Just calculates it, doesn't do anything. I'm going to add a click that takes a whole vector, a bool vector, just so you can click lots of things at the same time. Right, so that means that now known empty gets all the clicked ones set, and known borders must be ORed with ORed or exclusive ORed, or good enough, I guess. It should be 0 word. Was it known yet? With yeah, borders, which we got from the grid. It's more like that. Masked with all the ones that the known empty ones. To mask with is an ampersand. Known empty to mask. That should do the trick. So this sets all the bits where we now also know that you also know that it'll be empty. Assuming that whatever you click is empty, of course. Could add an assert for that, but well, it just works, so. And now I just completely redo this one by ORing it with the actual values and end it with the known empty things, but not as a boolean, but as a mask. So the to mask is doing multiplies everything with value masks. So all the ones are turned into well, all f's or something. All ones. what was it talking? Const vector is this argument discard qualifiers. Oh, toMask is a changer. Does not return something. Is that true? Yeah, it actually converts the thing. Oh well. Vector has no memory to mask. No, that's a bool vector. Don't empty is a bool vector. How is that possible? toMask returns a reference to a vector. So this must be a vector. Known empty is a vector. Vector has a toMask. Whilst vector has no member named toMask. No, it doesn't. But it returns that thing. What nonsense is this? Make it a bool vector and then call toMask, then it's hardly a bool vector still, or is it? Oh. I think I'm just going to change toMask. Right, well, let's do one deep there now. So we find the things that we can click on here. Click, is that returning something? Not returning something. No, of course not, it's not returning something. Calc new empty. Probably want to return that then. Vector, why is that not a boolean? Bool vector. Nah. So we do one time, click on the ones that we found, and then we show that again, what the result is, what the internal state of the solver. Right, yeah, this explode gives me, of course, possibly more than one thing. So I have to convert it to a boolean. How do you do that? I have to convert it to a boolean before I do the clear even. Clear is a vector, but probably also should be a bool vector then. I mean, known empty is a bool vector. And known mines is a bool vector. And edge should be a bool vector. Nobody knows what edge is. Edge is a bool vector. This is a pure boolean. So clear, yeah, we have to convert vector to a boolean. How do you do that? That sucks. I think the only way to do this is with an equals. So I could do equals 0. And then I have to invert it first. I want to find that are non-zero. How do we do that? Well, equals returns a bool vector. Yeah. Yeah, I can just do equals 0 and then the whole edge gets set, but we clear that in the end anyway. What's the problem here? I want to find the one that's a non-zero. So if I do equals 0, then we have a false everywhere where it's non-zero. So I have to invert it. And then we do the clear. How do I do that in invert? A Boolean invert. I think I'll just do once minus that. Could have used the inverse of edge. But well. This one is just once everywhere. Damn it, it's just Boolean mask. do not have that. Boolean mask. That's a vector in bool vector. That's exactly what I want. Except it's not const expression. Not sure if I need that. Probably not. See, exactly the same function. Mwahaha. Let's just delete this one then. And this one. And this one. Let's rename this one to Boolean mask. Because that's what it is. And again, but more efficient. I don't know. Now I have two of them. Okay, now I used an subtraction, but it's not how it works. Let's use a not to inverse the shit out of it. thing wants a name. Where did I lose my copy constructor? No idea. That is the real problem. In function const expression operator tilde. Oh, I fucking copied the const expression here, which I never wanted to do. And then screwed up everything. Oh no. Doesn't look new. Did I just write this? I copied another function. I thought. I just will make them all const expression. Especially that one. Hmm. Yeah. Well, actually, I don't know. No, that's not correct, because these, first it clicks this one, and then it clicks these 5. Now this one is 0, but the other one's not so much. That one borders 1, 2, 3. So this should be 3. This should be 3. Known borders is not updated correctly. Why? Kyra, I took hello. I'm doing fine, except that I should go shopping because didn't eat anything yet, and I'm just too addicted to my computer to get up and buy food. But the shops don't close they close in 1.5 hours, so I still have time to buy my breakfast. Yeah. Bad, Carlo. I think that as soon as I have this fixed, then I'll go do shopping. Known borders. Why is it not printing which seed it is using? It's quite annoying. I'm using a random number, am I not? Random number. Should be printing something. Oh, because it's static. So then it's not printing it because we didn't even reach main yet. Could add it to grid. Just make one grid. Nah, just put it in main. Random number reference. Random number. Which now has to be passed on to that one. You know, it prints a seed, so I can copy this. And then we can just construct that from that seed. And then we get the exact same output. And you know, when I like it. Let's like one that has multiple ones, like at least 2 maybe? Nah, maybe not. Just this one is good enough. And I still didn't fix that one. Known borders. Known borders is known borders, which is updated here. Whenever we click on something, create borders and known empty. Let's add some debug output here. Borders is grid borders. And known empty is known empty. Okay, so expected is that if you click on these things that we get numbers here. We get all zeros. And the reason we get all zeros is because probably I'm ending it with known empty, which is all zeros. Because there are definitely numbers here. Those numbers I want to see. Known empty is all zeros here. Oh, and they're not here. It's a big difference between these two. So what's that about then? Oh, known empty to mask. So, I mean, I just updated it. So before to mask and after to mask. Wait, known empty to mask. Let's print. Well, I know that one. It's all empty. Haha, all zeros. Known empty is the right thing, and then we do to mask and we get all zeros. To mask is broken. To mask. Wait a minute, do that again. Known empty is a bool vector. This is bool vector, so it returns a vector for the to mask vector here. Returns result. Oh, yeah, hello. Okay, let's copy this. That should fix it. Yes, now we have it. See, so known empty is this, and we convert it to a mask, then we just F, because it's just, bits is 4. And then we apply this mask to this, these values here, the borders. So we get 2, 1, 1, and so on. 2, 1, 1, 1, yep, 3, 1, 2. Okay. No, I'm going to do some shopping, I guess. Buy some food. At this point. Yeah, so we apply this again and nothing happens because we don't know any mines. I guess I could repeat this until it doesn't change anymore, and then it already should hang here. Did it click twice? 3 times even. Wow. What? No. Okay, now I'm confused. Mine, so we have 3 moves. 3 moves. First move, okay, we click on the in the corner. Click on the corner, and then we know that these 3 do not have mines, so we click on those as well. Now we know that these 2 have 2 mines, but this one doesn't have a mine either. And therefore we can also click on these 2. Okay, explain that. Yeah, that's completely correct. And then this one is a 2, but that one doesn't. So now we can click on those 2. Yep. And that's 2, 3. So now we can stop. But now we're going to the next move. So now we click on this one, which then results in being able to click on all of those, which then gives again 2 zeros here. So now we can click on those 2. And then we are at the end. And then we click on the third one, the first possible first move, which then gives us, of course, these 5 that we can click on. And then that one is a 0, so now we can click also on those 2, which gives us the end result immediately. So in the end, it always ends. It doesn't matter if you click on this one, or this one first. You just find all 3. Very good. Well, actually, the whole block of 2, all 8. This whole block. This whole block is the result of all 3 moves. Man, it's totally bug free. Totally bug free. So the next step is to click on known mines, because we can conclude, of course, that there is a mine somewhere maybe. Let me see if we can do that. Something is broken. Something is totally broken. We have mines out on the edge here. Why do I get mines on the edge? No, the mine generator is broken. Sorry guys, still cannot go shopping. No, but I have to. But the mines don't work. Solver. Who's generating my mines? That should be randomized. Randomize. VI solver randomize. So every time I click on that, but also the constructor, even that went wrong. And the constructor is simply calling randomize, and randomize is doing this. Randomize all the randomized things, and then do an AND with Boolean mask. Are you telling me that? Oh, that Boolean mask is no longer excluding the edge. Yeah, mines dot clear edge. Happy now? Yep, now it's all zeros. Whoa, see this one? It really finds the whole island, you know. So like this whole block is empty. Where's my mines? This whole block is empty. Therefore, it is immediately clear that we can click on that one, that one, that one, that one. Yeah, that's it. Those 4. Which it does. And I guess it doesn't really matter where you start either. It finds the same thing every time. 2, 3, 4. That should be it. Yep, super cool, man. Dark mode. I'm using this thing here. Dark reader. Dark reader. I am going to shop. I'm going to buy breakfast, finally. Yeah, I'll be back later.